So suppose we increase the number of variables. We've seen how to solve a system of linear equations in 2 variables. Well, what if we do it for up to 3? Well, we're going to use the exact same procedures. Elimination, substitution, exactly the same procedures. So what I'm going to do here is, as I look at these equations, the first thing that jumps out to me are I've got a positive x here and a negative x here. Right? Those will cancel each other really nicely. So I'm going to start, I'm just going to write them over. X plus 2y minus 3z equals negative 10. And negative x plus 2y plus 4z equals 9. And I'm going to add these two together and watch what happens. Right? That's 0. 4y plus z equals negative 1. Now notice, right, what happened here? I eliminated a variable. Went from 3 equations down to 2. Right now, which variable you start off eliminating is up to you. I had kind of a natural choice here with x because I had the plus and the minus there, right? So they're going to cancel. What I'm going to do now is I'm going to do this again with 2 different equations. Now, once you've picked a variable to eliminate, you got to stick with it. Right? So since I eliminated x on that first pass, I'm going to have to eliminate it again on my second one. So what I'm going to do is I'm going to take the third equation, 2x plus 3y minus 4z equals negative 13, and I'm going to take the second equation, but I'm going to multiply it by 2. And watch what happens. It becomes negative 2x plus 4y plus 8z equals 18. And now I've got you see I got this situation here with the x's where again I've got 2x and minus 2x, so these are going to cancel. What's left? Well, I've got 7y plus 4z equals 5. And now I've done it again. Right? I've created yet another equation that only has 2 variables. Look at where I am now. Now I have this equation in y and z, and I have this equation in y and z. So I'm down to a system of linear equations in 2 variables. I'm going to do it again. Right? I'm going to solve this smaller system. And this time I think I am going to use substitution because I can solve this first equation over here for z really easily. This is just z equals minus 4y minus 1. Then I'll substitute this into this equation here. Becomes 7y plus 4 times minus 4y minus 1 equals 5. Distribute the 4, 7y minus 16y minus 4 equals 5. And I combine the like terms. 7 minus 16, that's minus 9y minus 4 equals 5. Move the 4 over. Minus 9y equals 9. Now look at that. It comes out nice. Y equals negative 1. Okay. Now I've got the first third of my answer. I need a y value. That's great. I also need x and z values. And to find them, I'm going to do exactly what we did when we were doing this with 2 variables. I'm just going to start substituting back into the previous equations. So I'm going to take negative 1 and substitute it into here for y. This becomes z equals negative 4 times negative 1 minus 1. That's 4 minus 1. That's 3. Great. Now I have 2 of the 3 numbers that I need. So now I got to go back and pick one of the original equations. Doesn't matter which one you choose. I'm going to use the first one for no other reason than that it's on top. I'm going to put 3 in here for z, and I'm going to put negative 1 in here for y. And solve this. This is x minus 2 minus 9 equals negative 10. X minus 11 equals negative 10. Add 11, x equals 1. Now I have all 3 parts. Bring them together. Remember, we're not done. You have to explicitly answer the question. The solution would be the point 1, comma 3. Whoop, got them in the wrong order. X is 1, y is -1, z is 3. There's my final answer. So let's take a step back, kind of think about this from a high level again. What did we do? Well, I used the elimination method to eliminate the same variable twice. I eliminated x here, and I eliminated x again here using a different set of equations. The result was a system of linear equations in two variables. Right? So step 3 was to fall back a method we already talked about for solving systems of linear equations in two variables. And I used that to find one variable here. Then I started substituting. Substituted over here to find z. Then I took that y and z value and I substituted it over here to get x. And that gave me my final answer.